Good day to everyone. This video I'm going to discuss about the subject special electrical machines in that unit 4 permanent magnet synchronous motor, and the topic of discussion is microprocessor based control of permanent magnet synchronous motor. Now there is high demands for the control accuracy, flexibility, and for the ease of operation. So we are using the microprocessor based control, and it becomes very necessary nowadays. And this microprocessor based control replaces the conventional hardware control. The control algorithms which can be easily altered or improved without changing the hardware. So such simplifications of control algorithm and the reduced hardware requirement saves the control electronics cost and improves the system reliability. So this is the schematic diagram of the microprocessor based permanent magnet synchronous motor. So the permanent magnet synchronous motor is fed from a current source DC link converter. And this system consists of three-phase inverter DC link, three-phase rectifier system, in which the rectifier is fed from a three-phase AC supply. So the machine has a stator which is fitted with the conventional three-phase winding and permanent magnet on the rotor. So the motor operation is made self-synchronism by the addition of rotor position sensor that controls the firing angle for the inverter switches. Now, with respect to these firing angles, the inverter directs current through the stator windings in a control sequence. And the self control has been used increasingly such that it ensures that the armature and the rotor field move in synchronism for all point of operation. The characteristics of this drive depends on the DC link current, field current, and the inverter firing angle. These variables are independently controlled by the microprocessor to provide the desired features for all operating points. So in permanent magnet synchronous motor, the phase current is a sinusoidal function of rotor position, and the encoder and resolver or other high resolution sensor is used to obtain the position information with a required resolution. So in this sinusoidal brushless motor, the absolute rotor position information is required to at least 9 to 10 bit resolution. The sinusoidal reference current waveforms are generated with this precise position information. In the absolute optical encoder, an accurately patterned disk rotates between the light source, giving a unique digital output signal for every shaft position. The standard encoders are available with up to 60-bit resolution and with natural binary gray code or binary coded decimal output formats. So each bit in the digital world represents an independent track on the encoder disk, resulting in a complex and costly sensor. So in the schematic diagram shown, the system employs optical encoder, which is composed of a coded disk attached to the motor shaft and four optical sensors, thereby providing correlation between the rotor speed and the position signal. The inverter triggering pulses are synchronized to the rotor position signals with a delay, and it is determined by 8-bit control input. During normal operation, the inverter SCRs are naturally commutated by the machine voltage. The programmable counter, which is used for sensing the speed, is fed with train of pulses having high frequency proportional to the motor speed. The microprocessor gets the system variable signals like rotor position sensor, speed, DC link, current, etc. And the signal from the input output terminals, which issues the control signal to the rectifier and the inverter, such that the desired motor performance can be obtained with the help of this microprocessor based control system. So this class we have discussed about the microprocessor based control system of permanent magnet synchronous motor. Thank you, everyone.